This is Algebra 2 with trig. We're working on the 1B review. We've already completed the first side. We're now on the second side. We're looking for the equation using the table for the quadratic that's going to make this up. I notice that my y-intercept is where the y is 0. So my x value is p. The other 0, my x value is q. So p equals 1, q equals 3. So I'm going to use my equation. Well, let's take a step back. If we were to write an equation, we would say x minus p, x minus q. But I don't know the a value. There's multiple ways that we could do that. This is going down 15. This is going down 9. This is going down 3. This is going up 3, up 9, up 15. So notice how all those numbers are different. So that's called the first difference. We're now going to do the second difference, and we recognize that we're going up 6. This is up 6, up 6, up 6 more, and up 6 more. So the second difference is all the same. So that tells us that this is definitely quadratic. So we're going to take our a value. To figure out our a value, actually, we're going to take half of our second difference. Half of the 6 is our a value. So that's going to be 3. Now some people like to use algebra. I'll show you that here. We take the format of a times x minus p, x minus q. So I can use any point that I like that's provided. This seems like a nice point to use. It's not a vertex, it's not an x-intercept. X is 0, y is 9. It's a nice simple y-intercept. So I'm going to use the points 0, 9. And that's going to give us 9 for y. I don't know my a. 0 for my x. Negative 1 for p, or 1 minus negative. We're subtracting the p, which is 1. 0 minus the q. Okay, we're solving for a. This is 9 equals a, negative 1 times negative 3. 9 equals a. This becomes 3. When I divide by 3, you can see that the a value is also 3. So I can write my equation. Put the 3 in for the a, x minus p, x minus q. I wrote my equation. I have x-intercepts at 1, 0 and at 3, 0, my p and the q. My vertice would be, it's actually listed in the table, no additional calculations needed. So that's 2, negative 3. The y value of the vertex is between the repeating y values. So this is your vertex. So our axis of symmetry would be found where the vertex is at. So x equals 2. Notice that if this is your vertex, the numbers as they go out are getting larger. So this is opening upward, so it has a minimum. And the lowest number is negative 3, so that's called the minimum value. The domain is always all real numbers. You can continue this table on forever for x's. Any x you want to plug in, you can. And the range answers you're going to get is anything greater than or equal to negative 3. And our end behavior, as x approaches negative infinity, we know our function is going to go up because we said it's opening upwards. As we look to the right, we're opening upwards. Let's try that again. Here we have a table. We're going to write this equation in vertex form. I notice that I have some y values that match, y values that match, y values that match. So this is my vertex. I don't have any x-intercepts on this table. There's no spot where the y value is 0. So our vertex is 3, 2. My axis of symmetry is going to be the x value. And if you'll notice the vertex, the numbers are getting smaller to the side, so it's going to be opening downward, so it has a high point at y equals 2. We're going to write the equation. Well, we have to figure out what the x is. We can use algebra, or we can use the second difference. Your choice. This is going up by 5, up by 3, up by 1, down by 1, down by 3, and down by 5. Now we do it again. This is going down by 2, down by 2 more, down by 2 more, 2 more, and 2 more. So my second difference is -2. So my a value is going to be half the second difference. So the a value is -1. So I know that we're going to have y equals a x minus h squared plus k. Y equals negative or -1. X minus the h value is 3 squared plus the k value is 2. The domain for every quadratic is all real numbers. The range, notice that the points from the vertex are getting smaller and smaller to the right and to the left, so it has a high point. That means the y values are getting smaller or less than the 2. And the end behavior, as x approaches negative infinity, our function is going down. And as it approaches positive infinity, our function is going down. How do you know it's down? Because if you look at the table, this is your vertex. 1 is smaller, -2 is even smaller, -7 is even smaller. It's falling down, opening downwards, this parabola would. Here we have standard form. To graph standard form, very similar to the other quadratics, we're going to need to find the line of symmetry. The line of symmetry is done by x equals -b over 2a. Here I have a b value of -8. So -8 over 2 times a. That's 8 over 8, which is 1. So I have a line of symmetry at 1. So now I need to figure out what my y value of the vertex is. So I'm going to plug the y. To solve for y, I'm going to plug the x value back into the equation. So this is 4 times 1 minus 8 plus 2. 4 minus 8 plus 2. That's going to be -2. So we're going to have a y value at -2. Now our a value is 4. So we're going to use the same pattern we did before. Normally we go over 1. 1 times 1 is 1. But now we're going to times that by the a value, which is 4. So we're going to go up 4. There we are. You can reflect that. Next we're going to go over 2. 2 times 2 is 4. But we're going to times that by the a, which is 4 times 4. So that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4 times 4 is 16. It's 4 times the normal amount. This is very narrow as it opens up because the a value is 4. The range is going to be y is greater than or equal to -2. The domain, like all the others, is all real numbers. The y-intercept is always the c value, 0, 2. And if we were to convert this into vertex form, we already know what the vertex is. We found the vertex. The vertex is a line of symmetry, and the -2 we calculated. So y equals an a value of 4, x minus 1 squared minus 2. Now we're going to learn another process to find vertex form from standard form. And that's called completing the square. That's in the future. Okay, we'll pause the video and you can pick us up on the next one.